We're going to be talking about the square roots. Square roots. Hold this. Now, there's two different ways that you can write the square root. The square root is basically, okay, so for instance, I wanted to know what the square root of 100 was, okay?
Oh, so that's what that is.
It looks similar. What that look like what we've been doing in the past? What it
Division.
Look like division on it. But you see this little lash here?
Uh-huh.
Okay? That tells you that it's not division. Okay? We're talking about square roots. Okay? So the square roots is basically looking at something and finding out what times what equals this number. So the square root of 100 is just like saying 10 times 10 equals what?
100.
Okay, so the square root of 100 is what?
10.
No, it's 10. Okay, that's another way you can write it. Okay, it's like this here. It's still the same line. Okay, another way you can write it is 10 squared. You see that little 2? And then you got 2 of these. Not 10 times 2. Okay? 10 times 10. Okay, that's the difference. 10 times 2 is what?
10 times 10 is 100. 102.
I say it's 10 times 2.
Ah, 20.
20. But 10 times 10 is what?
100.
100, right. So you see that 2 is not saying 10 times 2 is 10 times 10. Okay? But sometimes you'll see this here. And we'll get there later. Okay? And I'm not even going to say that because I don't want to jump too far ahead of myself. So whenever we're looking at the square root, so if I ask you what the square root of, and I hope you've been doing your stuff, the square root of 81. Okay, what's the square root of 81? What times what equals 81?
So
a number times a number equals 81.
8 times...
No, not no 8. That's why I have you doing your multiplications every day. What times what equals 81?
Ah, 9 times 8.
You looked
No,
at that.
not 9 times 8. 9 times what, AJ? 9 times 9. 9 times 9 is 81, okay? So the square root of 81 is just like saying 9 times 9. See, this is what I tell you to do, not to be writing 1, 2, 3, 4, 5, 6, 7, 8, okay? When I tell you to do your stuff, you do it one at a time, so you'll notice stuff. And if you notice, I'm just going down. I started off with 10s, now I'm doing 9s. Hoping you would pick it up, but you didn't. So that let me know you ain't been doing what I told you to do. But anyway, the square root of 81 is what?
81.
Of course not. The square root of 81 is not 81. The square root of 81 is what?
No.
9. 9, okay? And what's another way of writing that? 9 squared. That little 2 means squared. Now what does that mean? 9 times what?
9, 10.
When you see that, what does that mean? Does that mean 9 times 2 or 9 times 9?
9 times...
Shouldn't take you that long, dude. We just talked about it here. Let's put keep it down here, Tom.
9?
Yeah, 9 times 9. Never 9 times 2. That's just 2 of this number. Whatever this number is. That's why they call it squared. Okay? This was 10 times 10. This is 9 times 9. Why? Because 9 times 1 is what? 9 times 9 is what?
81.
81. So we're talking so this is called 9 squared. Okay? 9 squared. Now when you want to say, you say, okay, what's the square root of something? You got to say the square root. You got to put this symbol here. Okay? So let's see if we can do something else. Okay, what's the square root of 36? And I'll put them in order because you know what I'm doing. What's the square root of 36?
So,
What times what?
6.
That's right. So the square root of 36 is just like saying what? 6 times 6, right? Okay, so the square root of 36 is what?
6.
6. What's another way you write it?
6 squares.
6 squared. Good job. And what that means? 6 times 2 or 6 times 6?
6 times 6.
Good job. Okay, and this is me introducing you guys. Have you guys ever done this? Have I ever showed you guys this? Okay, so this is your introduction.
I just thought I saw something on the calculator.
I know. But this is what we're gonna hold it up, Atara, so people can see. Okay, so the Hebrews can see when they see it. All right. Okay, so this is basically an introduction for you guys, and I wanted everybody to know this is your first time you guys are doing this. Okay, so let's try another one. Because after you guys get this, we got to get this down. Then I'm going to introduce you to something called the Pythagorean theorem. Pythagorean theorem. Pythagorean theory. Okay.
That's a long weird
it's
name.
Geometry. Okay. We're advancing. Remember we were solving for x. Okay.
I know.
But what I'm going to do,
what I'm going
to do is I'm going to bring your little sister in as well, so she won't be so far behind you. I know that you're 4th grade. Your sister is 2nd grade. But I'm going to try to tie her in as well because she's on division still. But we want to bring her into the loop, and she'll be doing what you're doing. But her questions will be a tad easier than yours, okay? But I want to bring her up to speed on this stuff as well. So, all right. So let's do another one. All right. So the square root of, let's see. Let me think. Be quiet.
How did you know you want to say something?
I'm daddy. I know everything. Square root of 25.
5.
Okay. Square root of 25 is just like saying 5 times 5, right? So the square root of 25 is what? 5. That's another way of writing that.
5 squared?
5 squared. That's right. So what does this mean? 5 times 2 or 5 times 5? 5 times 5. Okay.
So 3 5 instead.
Okay, so that's the square root of. Hold on. Okay, so the square root of 9. Atara, what's the square root of 9?
33.
That's right.
Wait, huh?
Square root of 9 is just like saying 3 times 3. So the square root of 9 is what?
3.
3. Okay, what's another way we can say that, Atara?
3.
3. What you call this little number up here?
2.
Nope.
Square.
Yeah, 3 squared. Okay? You got to listen. I know I'm talking to your brother, but I want you listening too, okay? Okay? So let's do another one. I was skipping line. Yeah, I was skipping line. Okay. Square root of 16, Atara. Come on, you can do this. What times what equals 16?
2.
Nope. 2 times 2 is what?
4.
That's right. 3 times 3 is what?
9.
Okay, 9. What about, let's keep going up. 4 times 4 is what?
8.
No, 4 times 2 is 8. 4 times 4 is what?
4 times 4, yeah.
You're looking at it, baby. 4 times 4 is?
16.
16. So the square root of 16 is just like saying what?
4 times 4.
4 times 4. So the square root of 16 is?
16.
No, the square root of 16 is?
4.
4. And this is my 2nd grader, guys, okay? This is the first time they're ever seeing this. So what's another way of saying this? The square root of 16 is 4. What's another way of saying it?
4.
4 squared.
Squared.
That's right. 4 squared. Okay? Okay, what about square root of 49? It's okay. The square root of 49. Can you see it real good? Okay. All right, keep it right there. What about the square root of 49?
Can this one too?
Go ahead, AJ. Square root of 49.
So.
Come on, you just didn't say it. Just say it. Don't second guess yourself. What times what number times itself equals 49?
So,
When you don't know, what would I tell you to do? Always start from what? A low number that you do know. 3 times 3 is what?
6,
3 times 3 is what?
9,
4 times 4 is what?
12,
16.
16,
5 times 5?
25,
6 times 6.
36.
7 times 7.
What?
You're looking at it, son.
Wait, what?
7. 49, that's right. See?
7.
So the square root of 49 is just like saying 7 times 7, right? Okay, so the square root of 49 is?
7.
7. So another way of saying that
7
is?
squares.
What?
7 squares.
7 squared.
Square.
Square ED. Squared.
Squared.
7 squared. Looks like y'all dreams out of school.
Yep,
Okay.
right. Idiot.
All right, so we got one more. The square root of 64. Atari, you know this one? Okay, so we did 10, we did 9, we did 7, we did 6, we did 5, 4, 3. Only thing we didn't do is 2 and 8.
Oh, I know this one. 8 and 8?
That's right. So the square root of 64
Good job, Tom.
is the same as saying 8 times 8.
Good job, Tom.
So the square root of 64 is 8.
Good
okay,
job.
what's another way of writing that?
Square.
What squared though?
Square root.
No. Another way is writing that. Look, we did all that. Okay? Everything's the same. Look, this is the same. No, this is 6 squared. This was 5 squared. This was 3 squared. This is 4 squared. This is 7 squared. This is
8 squared.
8 squared. That's right. Okay? So, another way of saying the square root, you said the square root of 64 was 8. Okay? Another way of saying it is what? 8 squared. All right? So we're going to go over this a few more times, and then we're going to learn the Pythagorean theorem.
That's a weird name.
Theorem, I know.
Pythagorean.
I'm sorry, Pythagorean. I said it wrong.
Pythagorean.
Pythagorean theory. Okay?
Pythagorean.
And it's basically what AJ likes. Okay? It's see, you can't be moved.
Pythagorean. Is that what I said? Pythagorean.
Yeah. Okay,
Pythagorean.
listen, okay? It's basically having, what shape is this?
Triangle.
A triangle.
My favorite shape.
But this is called a right triangle. Why? Because it has a 90-degree angle, a perfect L. You see that L? That's how you know, whenever you see, wherever the L, anytime you see, we talk about right triangles, anywhere you see that capital L, where you put the 2 L's at, that's where that 90-degree angle is, okay?
We saw this.
I know, degrees, okay? All right? And then, okay, so if I have a triangle like this, right? Where's the 90-degree angle? Or the right angle?
Right here?
Here, put it with the pencil. Where's the 90-degree angle? Perfect. All right? That's your 90-degree angle, okay? Now, you have okay? All right, that's your right triangle. Okay, hold this in. Okay, the next thing, okay, the longest line, okay, in this triangle is what? Is where? Yeah, okay, let's see. Let's say we're gonna have A, B, and C. Which one is the longest line?
Point C and point A.
No, which one is the longest line? One of them is longer than other.
Point C.
That's right, C. All right, that line is always going to be opposite of the 90-degree angle. Okay, so that's how you always know, because it's always opposite of.
Nine.
Listen, AJ, it's always opposite of the 90-degree angle. Okay, so when you find your 90-degree angle, your right angle, This longest line, okay, it has a name. You know what that name is called?
Pythagorean?
No, that's the name of the name is called a hypotenuse.
What?
Hypotenuse.
Hypotenuse. That's a weird name.
I think I spelled that right. Yeah, hypotenuse. Okay?
What?
Yeah.
That makes no sense.
That's the name of that. That's the name of that longest line. Okay.
That's a weird name.
And where is it always found? Opposite of the 90-degree angle. Okay, Atara? Now, we said the 90-degree angle is always inside that L, right? So I'm gonna give you one to work on. I want you to find the right angle.
The 90 degree?
That 90-degree angle. Where's that 90 degree? That perfect 90 degrees. Remember, it's a capital L. If it don't make a perfect capital L, then it's not it. You got to tell me. Show us. That's right. That's absolutely right. That's a 90-degree angle. Put 90 degrees and 90 with a little tiny capital O on top of it. Or 90 degrees, a 90 with a little O. Okay. You got it where you can see it, AJ? You got to make sure you can see it so other families, they see it. Okay. So, that's 90 degrees.
The whole thing.
Okay. So, that, now we've got to look for, because this is what I did with AJ. Look at Tara, pay attention, I'm talking to you. Okay? We have A, we have B, and we have C. Which one is the longest line? C, that's right. That is called the what? That longest line. Hypotenuse.
Hypotenuse.
Hypotenuse, okay?
That's a weird
That's
name.
the name. Yeah, I know. That's the name of that line, though, okay? The longest line. And it's always what? Opposite of your 90-degree angle, okay? Of your perfect right angle. So wherever you find that capital L, that's your perfect 90 degrees, okay? The hypotenuse is on top of that, okay? Or opposite of that, okay? So now, we have to, sometimes you have to get where you have to solve and find the what? That longest line. What's the name of that longest line?
Hypotenuse.
What's the name of it?
Hypotenuse.
Hypotenuse, that's right.
I said hypotenuse.
The formula for that, can you see it clearly, AJ? Let me see. Okay, have it now. Good job. Okay. The formula, okay, for that is, listen, you see how we have A, listen, look at her. We have A, B, and C. A, B, and C, okay? So,
D?
no, ain't no D. It's only three triangles, right? Three sides on the triangle, right? Okay, then. So, the formula for that, but sometimes you won't have, you have a number here. Say, for instance, this is 3.
2
this
and
is
1.
4, but there's no number for this, okay? So, we got to find out what is C, right? So, the formula for that is A squared plus B squared equals what?
C?
C squared, right? So, we know that, do we have a number for A?
Yes.
What's the number for A? Atara, what's the number for A?
3.
3. So, we know for A, that would be, to work this answer out, it would be 3 squared plus, do we have a number for B, AJ?
Yep.
What's the number?
4.
Okay, plus 4 squared equals what?
5 square.
No, equals what? C, equals C squared.
Ah.
Because there's no number for it, right? So, now we got to work them out. 3 squared, what's 3 squared? Atara.
3. 3
It's the same. That's saying 3 squared. That 2. What that 2 say? Do it mean 3 times 2 or 3 times 3?
3 times 3.
3 times 3. What's 3 times 3?
3 times 3.
9. That's right. So 3 squared is what?
9.
9. Okay, AJ, plus 4 squared. What's 4 squared? Do that mean 4 times 2 or 4 times 4?
4.
What's 4 times 4?
8. 16.
16. That's right. So 3 squared equals 9 plus 4 squared equals 16 equals what? C squared. All right? C squared. So 9 plus 16 equals what?
C square.
Okay? So 9 plus 16 is what?
C square.
No. But 9 plus 16 equals what? 25. Okay? 25 equals what?
C squared.
C squared. Okay? C squared. Now we just have to square root both of these sides. Because see, they want to find out what C is, not what C squared. All right? So now we got to take the square root of each side. Okay? So the square root of 25 is what? What times what equals 25, Tara?
9.
Nope. What times what equals 25? Okay, so the last number is a 5, so evidently got to be a number with 5. 5 times 1 is what?
5.
5 times 2?
10.
5 times 3?
15,
5 times 4?
20,
5 times 5?
5.
Okay, so the square root of 25 is what?
5.
5. There you go. 5 equals the square root of C. C squared equals what? C times C, which is C. Okay? So C equals what?
5.
So that number there is 5. You see how easy that was? Just took out. Yeah, it's not hard. It's easy. Okay? Now when we get older, it's going to be probably bigger numbers.
It will.
But it's the same identical thing, okay?
Uh-huh.
And that's how I just introduced you guys to the what? Pythagorean. Let me see if I can write it, spell it.
Pythagorean
theory. Okay?
Pythagorean theory.
I hope I spelled that right, okay? But I just introduced my fourth grade and my fourth grade son and my second grade daughter into geometry, okay?
Hello.
For X, and all praise to the Most High.
He did this.